Okay, so thanks and welcome again to our focus on the transportation industry with SOLIDWORKS Premium. All right, so what we'll look at today is what are the specific modeling features and add-ins in SOLIDWORKS Premium that will help you address your industry-specific needs and challenges. Some customers in your industry that are taking advantage of this design solution that SOLIDWORKS Premium offers. And then again, rather than focusing on it, I still do want to do a quick review of everything that is in SOLIDWORKS Premium, just so you get an idea of what all you're getting. And this is to, again, we just want to educate you because there is some great pricing. If you had ever thought of SOLIDWORKS Premium, this month is a good one. Because you can get it for the price of SOLIDWORKS Standard, and that's about all I need to say. You can get SOLIDWORKS Premium for the cost of SOLIDWORKS Standard. So you save a lot of money and you get a lot of extra functionality in your purchase. All right, so let's look at the market presence. Again, SOLIDWORKS kind of prides itself as not being designed specifically for any one type or a small handful of industries. They really do like to kind of be the jack of all trades to fit in every industry out there, and they do a good job of it. Again, that's why we're kind of focusing today on the automotive, aerospace. It's going to also include things like shipbuilding. Again, so we can kind of see that it has a good presence already in the industry in general. So people do know that it does suit their needs. But again, we're going to kind of show you why today. All right, so when we say aerospace and automotive, there are some other kind of related industries in there that we like to group together with this because they do share some similar geometry, similar types of challenges, and so that's going to be anything defense related, shipbuilding. It could be even just personal pleasure craft, pretty much anything in the transportation industry. So that could include rail also. I have a model of that. So again, and these types of industries all share these kind of common challenges, and especially for defense, you're never quite sure when a contract opportunity is going to come up. So we need to be able to go very fast once we see an opportunity. We have to be able to get designs finished and in front of people quickly because that gives us a competitive advantage. We need to be pretty nimble when these things arise. So and we'll show you how the modeling and just the ease of use of SOLIDWORKS helps you do that, and we can save time again by eliminating prototypes and doing lots of other stuff. We need to simulate the operating environment and ensure the safety of critical components because again, the transportation industry, it involves safety is a big thing there because lives and personal injury are at stake here. So we really need to make sure our designs are going to work. Things aren't going to fail unexpectedly. We need to know that going in, and again, rather than building multiple prototypes, we can save a lot of time if we can do some virtual testing, which the SOLIDWORKS simulation will allow us to do. We need to demonstrate these designs cost effectively, again, reducing the prototypes. We need to be able to get these in front of people without the long product design cycle, and the prototype and testing, physical testing iterations just take a lot of time and money. A lot of times we'll be involved with compliance. The FAA doesn't let you just release an airplane and go ahead and start selling it. There's a lot of requirements, safety especially, that you're going to have to meet. So we do have some tools in here, especially on the paper side, for managing revision control and making sure you have a paper trail. Some compliance with mil specs too, and DIM Expert helps us in there, so we can start to eliminate the paper drawing if that's what again is expected on the manufacturing side. And again, all of these different subgroups: rail, shipbuilding, aerospace, defense, automotive, they all they have these two challenges. First of all, they involve lots of large, complex mechanical assemblies. We're talking about power plants, propulsion systems, lots of routed systems for fluids and control systems, landing gear systems, lighting, electrical, avionics systems. There are lots of things going on in these, on the inside of these vehicles. So we need to be able to handle large assemblies in the first place, because that's just going to be an issue here. And SOLIDWORKS does offer some great tools, and we'll go over a few of those. And then on the other side, there's also lots of aesthetic or complex aerodynamic surfaces are also needed on the outside. So it's kind of two major challenges there. So we need a program that can, we can make sure we can do all the mechanical stuff as well as the more complex geometry too. So we'll give an example there of how the surface modeling can allow us to get some of these trickier shapes, like for aerodynamics and aesthetics. Okay, and again, a lot of aesthetics in general, we need to know what our design is going to look like before we start making prototypes too. So visualization of our product is also important, and we'll show you a good example of that. All right, so before we jump into a customer study, let's just get into SOLIDWORKS and do a little bit of live stuff and just have some fun. All right, so first of all, on the front of complex geometry, let's look at a wingtip here. It's based on a NACA 4412 airfoil, and then we're looking at some ways we can kind of alleviate or eliminate some drag at the wingtip or eliminate vortices, things like that. But again, obviously it's going to be a very complex surface, and and then at the end we're going to need a solid model so that we can maybe do some aerodynamics testing or some CFD or computational fluid dynamics virtually here on that to, again, before we build one, we can find out if our design is going to work. But let's go back in time and see how we would even make something like this in the first place. Okay, so first we have some great tools here for creating these curvy shapes, because again, there's not a lot of straight lines or arcs or radii, circular objects here. It's all very free-flowing, again, rather to reflect light and to look attractive or to be very smooth through a fluid. Okay, so we're going to need to be able to draw very smooth curves. Let's just wipe this one out and draw another one. So we have some great spline tools here. Again, we have a B-spline, we have style spline, and then again, for the more performance-driven, scientifically precise curves, we can do equation-driven curves also. So again, you should be able to get your contour or your shape on there. Let's just draw a quick spline here. All right, and I'm just drawing a point-to-point spline here, but you'll see how much control I have over it. All right, so now with the spline, we have these tangency and vector controls here, so we can start shaping it. One thing I like to do is show the curvature on there so I can make sure I'm not creating any wild inflections or wrinkles on this that are going to end up in a bad-looking surface. Okay, so we'll turn those on. It kind of gives me an idea what the curvature is doing, how it's ramping up and down. Make sure nothing too abrupt. Okay, and I'll pull that back, and you can see that curvature feedback on the fly. All right, and again, I'm just going to eyeball it here. Again, you may need something more precise, but you have all the controls you would ever need here. Let's see, I think that looks about right. And again, you see how you get that feedback immediately, and that would be a shape that we can then use to project a curve from two different profiles. So there's two different two-dimensional profiles here, and we can project them together to create this orange curve here, which is three-dimensional, as you can see. So the wingtip sweeps up and back. Get a little twist in it like that. Okay, so that's so we have tools for creating reference curves. Okay, and then when it comes time to start creating the surfaces themselves, let's just clear everything out and recreate this one here. Okay, so using those spline tools and sketches, we're going to create these nice contours here that we can build a framework that we can then lay a boundary surface over the top of, and it will adhere to that framework or that scaffolding. Okay, so these are just 2D sketches here, or profiles along the wing there. Okay, so in one direction, we're going to pick this top half of the airfoil shape, and then we're going to also pick out here on the wingtip that curve we created. Okay, so right away is just going from one of those curves to the next. Okay, not exactly what we want yet. Okay, so now in direction 2, when we start selecting these other intermediate sections or profiles, you'll see that the surface is now going to start laying down on top of those profiles. So the more I add in, again, it just keeps going down till it matches that curvature. Okay, we have lots of great tools for getting curvature continuity. I wouldn't say full-blown Class A for automotive sheet metal. Okay, that could be even C3 and higher. So, but again, for most applications, we can get curvature continuity or C2 or G2, which again is going to get you most of the way there. All right, so just like that, from some sketches and some projected curves, we can then create. We have these built-in, and this is just part of SOLIDWORKS standard. We have these built-in surfacing tools that will allow you to get those more, again, or aerodynamic or aesthetic shapes. And we have tools to evaluate the surface to make sure things are going to look okay. Again, this will give you a good idea how the light's going to reflect. Make sure we don't have any strange, wrinkles or divots, things that got in there, because again, that when we go to production, that's going to cost a lot of money to fix that. So we want to know here. So again, all these great built-in tools to get that type of geometry that's pretty that you run into quite a bit in your industry. All right, let's close that one, and then let's look at another one here. Again, I mentioned complex systems and large assemblies. Okay, this is a track setting machine. So this is in the rail industry, but this is just a machine to set the track. Imagine what just a full rail car would look like and how complex and large that assembly would be. So we definitely need to have built-in tools so that we can handle that and get these things open and get some work done on them rather than sitting around waiting or just running out of resources. So SOLIDWORKS, when we open this file, you'll see right here we have these modes, and these are built in. So we can do resolved or lightweight. Lightweight is a setting on each component that SOLIDWORKS sets to remove, without getting too deep into it, it removes some internal detail and reduces some display requirements just to free up your computer hardware resources. It's completely transparent to you. And we'll get into that a little bit more. There's also large assembly mode. The way that works is you set a threshold. I've got mine set to 500 components. So SOLIDWORKS looks at the assembly as it's opening it, and if there are more than that many components in it, it's automatically going to toggle this large assembly mode on, and it's going to start turning components lightweight. It's also going to do some system settings that help you manage performance a little bit better. It's kind of like a package of settings and model enhancements that when it's turned on, it frees up resources on your machine. But again, it's not that you have to know to go in there and what box to check. It just is grouped all those, and you just toggle it on or off, and you immediately see a performance boost. Then there's large design review. This is for getting into the tens of thousands of components where, just opening a model like that can take forever. It immediately gets you a graphic representation on the screen so you can at least start spinning it around and looking at it. And then it, again, it further reduces detail, again, because we're talking about massive, massive assemblies here. And it allows you to at least get a model open and have a meeting about it, make notes and take snapshots of it. which would then allow you to then go back, work on the model, and make those changes that you had in your discussion. Again, rather than waiting for a fully resolved model just so you can show someone in your chain, what something looks like, or to have a discussion. So that's large design review. Again, a lot of these things just built into the SOLIDWORKS because they know we need to get work done and we need to be able to manage the performance. Okay, so let's look at some things that are included in SOLIDWORKS Professional and Premium that will help you in this sense here. When we look at this, we've got, again, speaking of routed systems, we got a lot of complexity on the inside of here. We've got hydraulic lines, we've got electrical cabling, you may have fixed piping, with elbows and flanges, flexible tubing. It could be lots of different types of things, but you're basically, moving fluids, and you need to go from one connector or fixture to another. Okay, so rather than doing that by hand, routing will automate that greatly, because again, what most people do they'll do everything but the routed systems, and then they'll build it, and then they'll try to work those in, and then they'll find out there's problems, and then they got to go back and change the original assembly. When you could have integrated it at the beginning of the design, then those problems will show up a lot earlier. And again, because they're in your model, you'll get an absolutely accurate bill of materials, which is huge for purchasing, and our data management. You can get hose lengths, pipe lengths, cable lengths, quantities of connectors, everything you use just by dragging and dropping into your assembly. All right, so let's open this sub-assembly here and see what we can do. First, let's do the toolbox. So this is something in Professional. That is helpful. Sorry, I should have suppressed that bolt, but let's just have some fun here. So lots of hardware, standard fasteners. So again, to get an accurate bill of materials, we want those in the model, but it can be pretty tedious if there's a lot of it in your specific designs. So with Professional, you get Toolbox. Obviously, with Premium, you do too. With Premium, you get everything in Professional and more. So always remember that. It's not really one or the other. It's just each level, you just get more stuff to help you out. So what this is a standard library of hardware, over 1 million different parts in here, and we're talking bolts and washers and nuts and cotter pins and gears and O-rings. You can see it on there, retaining rings, any kind of standard fastener that isn't going to be changing, that's off the shelf. There's no reason for you to spend time drawing it and individually inserting one by one each fastener that's going to be in your assembly, because again, we're trying to get to that accurate bill of material, so it needs to be in there, but it also takes a lot of time if we're doing it manually. So let's dig into our bolts here. We'll go into, grab a hex head bolt. And now when I drag it out, you can see I get a little ghosted image there, and if I just mouse over that hole, it snaps into place. So it saves me the hassle of having to tell it to be concentric in the hole and have the head sit down on the face. You'll notice it measures the hole and tells me that it picks the correct size, which is an M20. So that saves me time. Of course, I just want the size that fits in the hole. I shouldn't have to, if I do it manually, it leaves me open to making a mistake. And the good news is you can also size that, and if the hole changes, the bolt will update too. So again, it just takes some of that, all that updating out of your hands and does it automatically as it should be. So we've got the correct size on here. I always like to show some threads. And now we just need to pull the length. Okay, and you can see it. We'll pull it through that other nut. Okay, so we'll go with, and you notice it's only giving me standard increments there. It's not letting me pick a 152 millimeter length. That doesn't exist. So it's already aware of all those things. Okay, we pull one of those down. Now it's all set up, and now I can just go and drop that bolt in any hole that needs it. Here's another one, and again, it's just one single click to put it into place. On to the next. Okay, so you can see where this would be a huge time saver if your design has a lot of different fasteners in there. There we go. So we got those 4 in there. Looking good. And the same would work now. We already have a nut on there welded on, but now I could go to the nuts and snap those on there too. Okay, full set, flange nuts and all types of different standards. Just depends on which standard you're working in. It'll have the standard components in there, but that's a huge time saver. Okay, and on terms of the routed systems, we don't need to look at the tracks here anymore. Let's take a look at that and how routing can help us out here. And I opened the wrong assembly. Sorry about that. My mistake. I'm sorry about that. I'm opening the wrong things. Here we go. I need to open the assembly it belongs to. There we go, but it makes it easy to identify. All right, so here's this subsystem here. And what routing can do, and again, you can see we've got electrical, we've got rigid tubing, we've got flexible hydraulic tubing. And so what routing it does is gives you yet another library. And we can see you've got conduit and electrical, HVAC stuff for ducting, rigid piping, your electrical things, tubing, then we've got clips and elbows and grommets and other types of fittings and tees and unions, again, to help you route your fluid to wherever it needs to go. So these all parts are standard and they're in there, and so what we could then do is just drag and drop a connector, and then once we tell it where we want it to go, let's see, then we can just easily route point to point. Okay, so on this one, if I didn't like where it went, I will just show you that it gives you control over the spline so that I can tell it, again, run through a pass-through or a grommet or a hole or a clip, or some kind of cable management. But you can see it just gives you this, and it does this automatically rather than you having to hand draw it. So now when it comes time, if I need to make changes, there's some easy tools here to just move this, make sure it's clear of any kind of component that I was worried about. We can also, we can set fixed length splines. So if we know we have a known length of hose that we have to work with, then we can just set that, and then it'll limit that, and we can only manipulate it at that length. Okay, but again, very easy tools to do these very complex things quickly. Again, because there could be a lot of these in your model. So we want to make sure that we're going as fast as we can to get this done. And again, we're going to get our accurate bill of materials. So that's again a huge help for these in this industry because of all the need for routed systems. Okay, let's take a look at a customer that's actually using quite a bit of this stuff right now. And that is Kvichak Marine in Washington. This is one of our customers, and they're doing quite an impressive job.
we've seen a dramatic decline in the amount of rework due to engineering. This particular boat, we would have never been able to build it in 2D. There's piping that runs through a section of the boat that was only accessible in the very early stages of the construction. So we had to be able to see every single pipe in this project, lay it out in detail, and all the interactions of the mechanical system before we ever started building. All our modules can have all of the design intent pre-built into them. We can see all the connections, say for an engine, already laid out, all the exhaust, everything's connected together in 3D modules. It also allows us to retain much more of the engineering knowledge in the design itself. So as the customer is trying to sort out what they really want, we're not throwing away any of the engineering that we've done before. We have an extensive parts library that we've built up over the years. Every time we need something, we make sure that we model it to a standard which will allow us to use it on other boats. And that's one of the ways that we can be competitive, is to be able to leverage all of the past engineering that we've done in the next project. Some of the systems, like the structure of the boat, we can define earlier in the process. We can get plate to the cutting facility much earlier in the process because we can start releasing things as we go, especially since we build in a very modular method. We work with one of the most expensive materials we can work with. Short of being fighter planes made out of titanium, aluminum is expensive. The more efficient we're getting with our material processing, getting all of these components into our nesting programs, getting more efficient nests, we're seeing pretty significant declines in the amount of scrap we send out. We're able to save a lot of money there, tens of thousands of dollars for every boat we build. The 3D environment, I believe, really helped us to do it right the first time. It didn't depend so much on the engineer to be able to keep the 3D model in his head. It was actually right there, helping keep the vision of the project on track.
All right. So again, great example of someone taking advantage. As you saw the size of those boats, right? So again, talking about massive assemblies, as well as all those piping systems going throughout the ship in very tight quarters and sometimes with no way out. So again, it's nice to be able to do that up front and early to make sure it's going to work before you have to start fixing things after you've already built it. All right, let's go jump back into SOLIDWORKS and take a look at the simulation side. How do we know that things are going to be safe? Again, this industry we work in, safety is huge. It's a requirement, not just a good idea. All right. So let's open a few here. Let's take a look first at an automotive part. Again, just going to show simple linear static abilities of SOLIDWORKS Premium, which includes simulation standard. We're going to be talking about how you can take it even further than that, but again, just talking about what's in SOLIDWORKS Premium right now. So this is a spindle that's part of a hub assembly on a car at the end of an axle, part of the whole suspension system. And again, with automotive as well as aerospace, weight is always a factor. So we need it to be safe and not break, obviously, but we also need to get into the air, or we need to reduce our fuel costs. So it needs to be as light as possible while still maintaining that factor of safety. So again, as opposed to building these by hand and then physically testing them, it'd be nice to get some insight before we go spend the time and money on that. So, and hopefully reduce the amount of times that we have to do that. All right, so let's just look here at, again, with our add-ins. There's just part of SOLIDWORKS Premium. This is all the things you get, and so we're just going to turn it on. Okay, I've already created one study, but let's do one from scratch just so you can see how something complex can be made very easy in SOLIDWORKS. They've done a great job with the interface and kind of taking it out of the hands of the specialists and allowing any engineer, designer to at least do some first pass sanity checks just to make sure they're going in the right direction or look for some trends. you know, again, it just helps you, it gives you insight into your design and helps you design a better part. So again, this is going to be seeing a load, and so let's just set that up. So with simulation, we're just going to start a new analysis or study. And here's a really good example of, in the higher levels of SOLIDWORKS simulation, you can get to solve some very specific but very complex problems depending on what you need. Again, I'm just going to be focusing on the linear static because that's what you get with SOLIDWORKS Premium. But just know, if your needs are more, you can always go much farther with the simulation package. There's Simulation Professional and Premium, as well as some very specialized non-linear and some other things that you can do that start to get very advanced. Not everyone needs it, but again, the possibility is there. So we're just going to do a static study. All right, and it makes it very easy. It just gives us a checklist here, and we just need to go down and meet all those requirements or boundary conditions, and then it'll do the analysis for us. So let's take a look. Again, keeping it simple here, but we just want you to just get an idea of how easy this is to use. The material is cast alloy steel, so that has all the material properties which are necessary in order to do one of these studies. It needs to be locked down in space. So with the fixture, we're just going to fix that top face where it would attach. But you can see here, then you can also allow some roller or slider action in certain planes or directions. Again, so you can always, you know, accurately simulate the condition that the part's going to be seeing in the real world. All right, so there we go. So we fixed that top face. Now we need to have a load acting on the part. And you can see here all kinds of different types of loads that you can put on it. We're just going to put a force acting right here where the hub attaches. Okay, except that's not exactly how the force is going to be acting, or at least not the way we want to look at it. So we can then go in and point that force in a certain direction using a reference here. Okay, so along this direction, yeah, arrows look good, acting up, yep. And we'll do 1,000 pounds. Okay, so the part's fixed. We have a force acting on it. So now it needs to be meshed, which means it needs to be broken up into known elements so that it can run all these equations. Okay, fantastic mesh controls here. I'm going to just go with the default, but you have a lot of control over refining the mesh in certain areas where you may have hot spots, and it's also a very fast mesher. Like about that fast. So now we can actually see all those elements, which is what allows it to run all the equations, those known physics equations on this part. So now once that's done, we just tell it to run. I've already done this and then looked at it, and it just ran about 44,000 equations. Better it than me. And then we get a nice picture, a deformed picture of what's happening. That makes sense. Sanity check. Yep, force is acting up. I would expect it to kind of bend around the arm like that. Okay, we get a number right away, about 13,000 psi, and we can tell that it's about 1/3 of our yield strength. So that's good. We're not seeing too much stress, you know, based on what the part is made of. So that's good, at least right away, that this thing's not failing. It's good to know. We can also get an animation of that. It's a little fast. But just to, again, so you can see the behavior and to see how the stress builds up like that. Again, anything to get some insight into what's going on in your part. We can also get something like displacement. Again, maybe it's not failing, but it is going to move, and that's in the design, that it is going to displace and flex a little bit. Well, we may need to know what that is. Let's get a little bit more detail here. Let's go 3 decimals. There we go. So it's moving about, what is that, 30,000. Okay, so that's fine, but at least we know maybe we need to plan accordingly and not put something too close to it. Again, you're just getting more information about your design. And then a factor of safety plot is interesting. Let's go in and set this. Let's just say I want to see everything below factor of safety of 100. Looking at PSI, yep. All right, so right there. So the blue, that, so the lowest factor of safety we're seeing is 2.7. So that's pretty good. Maybe we're a little overbuilt, and what that tells me as a designer is, maybe I can start removing some material now. Okay, that's really good information. Again, for aerospace and automotive, we're always trying to make it as light as possible. Okay, and here's one of the advantages of simulation just being built right into and integrated into your SOLIDWORKS interface, is that now I can just go back to the model, make some changes. Let's do a test here. We're going to see how much does this thing weigh. 9.9 pounds. Okay, yeah, I'd like to get that down a little bit. So we'll just find a dimension here, like the thickness. Yeah, it looked like it didn't need to be that thick. Let's go down to a little less than an inch. Okay, so now obviously we know SOLIDWORKS and parametrics, the geometry updates, looks good. Back to the study. Okay, we don't lose any of our boundary conditions. We don't have to set it all up again, which is nice. We don't even have to leave this piece of software, which is very nice. However, the geometry is changed, so we will have to, run it again. But that's it. And we know it did it really fast, and there we have it. Okay, so we're seeing, about 10,000 PSI more in stress, but we're still not close to our yield strength. That's good news. Okay, maybe there's a little room to go even. The displacement now is about 66 thou as opposed to 30 thou, so we do know it's going to move and flex a little bit more, okay, but it's still within limits. Again, and we can then see how our factor of safety is now. It's down to 1.5, so we're still in good shape, but again, now it's up to us where do we want to be. But again, we just took, here's the payoff right here. Where are we? 8.9 pounds. We just took a pound out of that part without breaking it, without sacrificing anything. So this is why simulation is great, to be able to do this here without ever cutting metal or taking the time and money to make as many prototypes. That's the whole idea. And we'll show you this is another good one here. And this is a little bit of an idea of how you can get even more advanced, although again, it's outside the scope of premium, but just know there's a lot more you can do with simulation if necessary. So what we've done here is with SOLIDWORKS flow simulation, which again is not part of premium, but is available for people who need to study fluid dynamics on their models. We ran a study in that, and you're able then to transfer the load determined by that fluid flow, and then transfer that as a force into our simulation model here, and then run a stress test on it. So that's extremely helpful. So we ran some tests here and found out what's going on. What's nice is that, we can see that there is some stress in it, but looking at the model, it's not really on the outer component at all. That seems to be handling things just fine. So where is the stress? I can see I got a little marker here that it is somewhere buried in there. By the way, sorry, this is an add-on antenna for the fuselage of an aircraft. So again, to get more insight into your design, we can then do things like section clipping, basically look inside the model. Okay, and if we really look inside here, we can see it's not so much the aerodynamic part, it's that antenna dipole on the inside, because its enclosure is flexing, it's causing that antenna dipole to flex also, which may not be okay with that material. But again, I'm glad we found it out here rather than flying it and finding out that our signal failed and then find out it's because we broke the antenna, even though the outer enclosure was fine. So again, this kind of stuff can be extremely valuable to find out early in the design phase and help you avoid some problems. But some other things we can do is, frequency analysis. And it'll give you different mode shapes and those frequencies. Okay, it's really good to know. And we can do random vibration and all kinds of dynamics. So again, we can get pretty deep, depending on how strong your need is for these very specific studies. So just know you can always start with simulation, and there's always room to go do much more in it, if necessary. All right. So a couple case studies here of people using that. Here's a builder, a car builder in Australia who was able to cut design cycles by 50%. Like, these are the things that really mean something, because, and again, you can see how, where if I'm able to design a part that I know when I build the prototype, I'm pretty darn sure how it's going to behave, and I maybe make that one prototype, maybe a second, and that's it. And as opposed to just multiple iterations, which take so much time. Development costs go down because of that. You're using less material, less scrap, less mistakes. Things go together better because, again, we're in 3D and we can check alignment of holes and collision detection and interference and all these things, and we know ahead of time before this thing ever becomes a reality. Okay, and another one what would be similar to that sample that we created was, again, for someone who creates support systems for aircraft and retrofit systems, BAE Systems, their division in Florida. And again, they needed to know that this is on the field. They can show up with this thing and it's going to bolt right onto the plane, and they need to know how it's going to behave. So again, simulation was a big part of that in helping them get there. All right, and for the last hands-on, let's do something fun with visualization. As I said, these products in this field, they need to either be very efficient through the air or they need to look really good. And that's just, it just goes with the territory, and that's fine. So we do need to, have a pretty good idea of what this thing's going to look like ahead of time before we build it and realize we don't like it. Okay, so now we can load in our SOLIDWORKS model, and so SOLIDWORKS Visualize allows us to easily paint the model and see how things are going. Let's start in the easy mode here. Okay, so nice simple interface. We can move our model around, okay, depending on what we want to do. All right, and to paint it, again, we have some materials. Let's try, what would this thing look like in green? And when it's automotive paint, it's actual automotive paint. It has settings for flake and clear coat, so it is specifically for, it actually started out as bunk speed, which again was used widely in the automotive industry. That's why it has so many specific features and functions for that industry. So again, if that's where you are, this is the tool to visualize your products. You can see where you can just drag materials though and easily change things and just get a quick what if. How would this look? Would we like this? I don't know. Okay, maybe some tinted glass. There we go, looks good. Okay, but right away, and it's rendering on your screen, so you get a good idea. And then when it's time to go out and really do an output, a high quality output, whether it's for print quality or animations or other things, it's all in here. Again, there's now a Visualize standard, which is only going to be static output, so extremely high quality, high DPI rendered images. Okay, photographic quality. So that's going to be possible in Visualize Standard. If you need more, Visualize Professional offers more dynamic kind of outputs like VRs and panoramas, turntable animations, animations in general, some special effects, things like that are also included in here. And again, so it just depends on your needs, but this is the program to visualize your product. Let's do a couple things that may be fun. Let's just look at the turntable. Okay, so rather than me having to set up an animation, we can just set the turntable to move for us, and then when we render it, we can have it rendered like that, so you get a look at every single angle in one file. Okay, and we can reverse it. Again, this is a very common way to display vehicles, and so it's just built right in here. You don't have to fake it or come up with a workaround. This is what it's for. Okay, so we'll reset it. All right, and let's look at, let's kind of bring it in a little bit here. Zoom in. And if we go to cameras, we can also animate a camera. And just like that, it's just a right click, and it's all done for you. So again, this would be another way to get a quick rotational animation without having to really do too much or worry about the timeline. You could always go in there and make changes to fine tune it yourself, but again, it's very easy to do here. Let's look at how we can animate a wheel. Let's put Chrome back on that wheel, I think. Man, that's easy to do. Yep, I like that better. That's all it took for me to figure that out. All right, so let's see what this will look like. All right, so we're going to select that wheel. And what I want to do is set the pivot point for it so that it rotates on its axis. Okay, and then I want to set a rotation animation for it. Okay, I'll go in here and I have some controls over how, which direction it rotates around, how fast. Let's do 1080, have it go around several times. It looks like it might be going backwards. Let's put a minus in front of that. Okay, and you have controls to ease it in and out. So again, really nice way to do it here. All right, and then we can just play the animation. Oops. There we go. All the way to the back. All right, so there's our animation of the wheel, again, without too much trouble at all. So let's, it'll spin a little faster if we shorten that up. There we go. It's doing the same amount of turns in shorter time. That looks good. Now this is where it gets really interesting, is we can add a motion blur. So that's a camera effect here. And so it'd give that kind of like a spinning propeller or a spinning gear or wheel, give it that, that sense of motion or speed, even better. So we'll just turn that on. I'll dial this up a little bit. All right, and once that's done, then if I go to a different render mode here, you'll start to see that the wheel turn and blur as it does each rendering pass here. Notice the flake in the paint too. So once now it's really starting to crunch away on the rendering, and it's going to get very realistic. But again, it's just for my on-screen preview. But this is the accurate mode, which gives me a really good look at what the final output's going to look like. So right there, without doing too much, I mean, that looks fantastic. So again, that's a really nice way to add realism and a little drama, emotion to your rendering. And there's a whole lot more you can do in this. We have a lot of information about Visualize Professional and what's available, but just know if you have SOLIDWORKS Premium, you get Visualize Standard, so you'll have the highest quality renders possible, in addition to the PhotoView 360, which is still in SOLIDWORKS, and that's integrated right into SOLIDWORKS. We like to think that's a good one for a first pass, just to make sure things are looking okay. This is where you're going to go in Visualize here if you need the highest quality photographic output. All right. So again, let's look at here some things that can help us really handle those challenges we run into. Is the routing for sure, routed systems, electrical, cooling lines, fuel lines, brake lines, hydraulic, any of that stuff that's going to be in these type of vehicles and products, easily done with the routing. Simulation is a huge point because we need to ensure safety while keeping weight down on these components. And just know, again, besides the linear static, you can take it very far into very complex studies. Aesthetics are a major part of this industry we're talking about today, and so we need to be able to make sure things are going to look the way we expect and get some insight and feedback on what they look like and to know to make changes early in the design cycle. And then toolbox, like I said, for all those standard componentry like fasteners, that's a huge time saver if you use anything but more than a handful of those parts in your designs, because you're going to be spending more time on that than anything else. All right. PDM also gives you a strict revision control data management system and secure vaulting. So you can always, show how your product development cycle look like. If anything goes wrong, we have complete coverage. We always know we're using the right version. So SOLIDWORKS PDM definitely helps with that. Again, the large assembly tools, things I didn't mention like SpeedPack are other ways that we can just use graphical bodies without needing all of the detail all of the time on the entire model. Again, just frees up resources. We've got, again, just standard modeling tools are fantastic, even for the very complex type of shapes. So again, standard is going to give you all these things that we're used to with parts, assemblies, drawings, and then specific tools for sheet metal and weldments and surfacing, which was the big one. But again, we may have welded frames, so that's a big help there too. And then professional is going to add to that. So it's everything in standard plus the file management, the PDM, the toolbox, the Visualize, eDrawings Professional to help share information with non-CAD users, so they have a model they can spin around and comment on and measure and mark up. It also includes, if you're using circuit boards, we can bring in circuit board files from ECAD programs or PCB programs, so that we can integrate those early in the design to make sure they're going to fit and not get too hot. We can do some scanning and reverse engineering. If we have a foam model or something else that we need to get into CAD, we can read those point cloud files or those scan files and build solid models from them. And also a tolerance analysis program in here too to help you see where you can maybe tighten things up to ensure fit and finish, but where maybe you can also loosen things up to save some money. It'll give you a really good idea of what the greatest contributors are to something being out of tolerance, without having to use spreadsheets and a lot of hand calculating. So that's also very very important for just product quality. Okay, so there's PDM standard in SOLIDWORKS Professional, and that's for smaller groups, but again, it has some basic workflows as well as that revision control we're talking about. If you do need it to do more, there is a PDM professional version that does a lot more and handles huge design groups and multiple locations. So again, it just depends on your situation, but we have the solution for that. Toolbox, as I mentioned, over 1 million pieces. I mean, you definitely don't want to draw these by hand if you're using a lot of these. The photorealistic rendering with 2 programs now. Visualize is new and built on some very high-end technology from NVIDIA. So calculating the light and is extremely accurate in photographic quality. The interesting thing about Visualize is it can be used separately from the SOLIDWORKS license it's attached to. So someone could be designing in SOLIDWORKS, someone else can be using the Visualize that's attached to that seat to do the rendering. So you don't take up a SOLIDWORKS license just to do some photo rendering. That's a pretty nice difference there too. And eDrawings Professional again gives you like a neutral 3D model that can be viewed on any kind of Mac or PC, and you can also pull off measurements and put feedback on there rather than faxing drawings around, so that helps quite a bit. There's cost estimation also for sheet metal parts, 3D printed parts, plastic parts, cast parts, weldments. So depending on the type of model you have, it has different automated methods for calculating the cost of a part, and that helps you as a designer because you can see as you make changes to your part if you're making it more or less expensive. So it helps you design for cost. If you're a fabricator, it helps you quote designs very easily if you can just get the 3D model rather than all the tribal knowledge that most people use in a spreadsheet somewhere. CircuitWorks integration, as I mentioned. Design Checker is nice because it allows you to set your company standards for things like decimal places and drawing standards and fonts, spell check, different things like that, and then it's just a batch file that runs against a whole pile of drawings and tells you which ones are wrong and can even automatically fix them rather than you opening each drawing one by one and having to do it yourself. Okay, that's a good visual there. Imagine that dropped on your desk and now you have to review every single one of those drawings. So that it can automate a big part of that. The task scheduler is the same thing. It just automates some other types of tasks. Rather than you having to do it on a file one by one, you can point to an entire folder and run an operation on every drawing file in that folder, every part, whatever. And it just helps you, and you can do it, outside of working hours and then come back in the morning and your tasks are done. Again, just allowing you to do more with less. The tolerance analysis, as I said, gives you that insight into what's contributing to your critical measurement being out of tolerance. Yeah, there's something that I wouldn't want to draw in any CAD program. And so being able to scan certain things is a really helpful, especially for ergonomics or something like that. Anything the human body is tricky to get into CAD, and so if we can scan it and just get a 3D model, that's a nice way to go too. All right, and then Premium is going to give you all of that we just looked at, plus the simulation we looked at quite in depth. A motion analysis tool, kinematic motion analysis, to help you figure out what loads are going to be required to actuate something, and then allow you to source a motor or actuator correctly based now that you know what the load is or what the power requirement is. So you can do some kinematic analysis also. The routing. There's advanced surface flattening. So if you're doing things like graphics or textiles and something like that that are flat things that are needing to conform to complex surfaces, we need to kind of know where where any kind of compression or tension is going to be happening. So we may need to add reliefs or something like that to make sure things are going to fit. But it is nice to be able to get a flat shape for a compound surface. Pretty hard to do. And then we can take the costing one step further in Premium by just doing an assembly level. So each part gets its own automatic costing, and then it's rolled up to the top level, so you have that assembly cost information rather than having to add it all up yourself at the end. And the last thing is SOLIDWORKS sustainability. If you're concerned about what kind of environmental effects that your designs are going to have throughout its life cycle, this will tell you based on things like the manufacturing method, the type of transportation, what materials are in it, what happens to it at the end of its life. It looks at all those factors and gives you some measurements onto what kind of effects, environmental impact it's going to have, and it allows you to then maybe change materials or manufacturing methods and see how if it'll make things better or worse. So again, it's pretty powerful stuff, database just built into the SOLIDWORKS to help you also search alternate materials. And with that, I'm sorry we went just over an hour, but hopefully you got an idea of those of you in the transportation industry on how SOLIDWORKS Premium can help you do your job better and get it done faster with less mistakes. Thanks for attending. This is Todd at Hawkridge, and we will look for you next week when we look at the SOLIDWORKS Premium and the consumer product design industry.